Today we're going to talk about multiplication properties of exponents. So title your notes 7-1, Multiplication Properties of Exponents. Recall that a monomial, or a term, is a number, a variable, or the product of a number and one or more variables with non-negative integer exponents. Remember that product means multiply, okay, and non-negative means that it's positive. I want you to pause the video and determine whether each expression is a monomial. 7 is a monomial because it is a number. Okay? It is also known as a constant because it does not contain a variable. X plus 12 is not a monomial because it consists of two monomials, so it is actually called a binomial. N squared is the product of two variables, n times n, so that is a monomial. T is a monomial because it is a variable. X divided by y is not a monomial. Because it's actually the quotient of two variables. Now f is going to be a little trickier. It's actually 1/3 times r times t. So it is a monomial because it's the product of a number and two variables. So notice this is not a monomial because there's a variable in the denominator. Okay, it's the quotient of two variables. Here, we're actually taking the product of a fraction and two variables. Previously, we talked about powers. Now, powers consist of a base and an exponent. Okay, so we're going to be using that word power in the next few definitions. So it's important to know that that consists of this whole entire thing, the base and the exponent. Okay, the first rule we're going to learn is product of powers. When in doubt, give yourself a simple example and write it in expanded form. So let's look. Let's see if we can figure out this rule. So x to the fourth means x times x times x times x, and x to the third means x times x times x. So this is equal to x to the 7th because there are 7 x's multiplied by itself. So can you imagine what the rule might be for taking the product of two powers with the same base? Let's try another example and see if we can come up with that rule. We have 6 times -2. So first we're going to multiply the coefficients, and then we have n times 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 n. So we have n squared times n to the 7th, and that will give us 6 times -2, -12, n to the 9th. And the last one, now we have different monomials that have two variables. So we have, remember that the ghost one is here, so we have 3 times 1, and then we have p, so I'm going to group these together, p to the first and times p to the third, and then we have t to the third times t to the fourth. So this is going to be 3 p to the, remember this p to the first, so p to the fourth times t to the 7th. Hopefully by now you've figured out the rule for a product of powers. To multiply two powers with the same base, simply add their exponents. So this is a really good thing to write down on your notes page. In your book, and if you talk to any mathematician, they will show you something that looks like this. And it just shows the rule. If you have a to the m times a to the p, you simply add the exponents. Okay, and some examples sometimes are easier to look at. You have b to the third times b to the fifth. So you add 3 plus 5, and that gives us 8. Remembering that this is b times 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 b. All right, the next rule we're going to learn is a power of a power. So let's write this out in expanded form and see if we can come up with the rule. We have x squared times x squared times x squared 3 times. Remember that the exponent tells us what we're going to repeat, what our base is, repeated 3 times. So if we write this all out, that is going to be x times x times x times x times x times x, which is x to the 6th power. Think about how these two are related. What will you do when you're taking the power of a power? What about this one? This looks really complicated, but let's start inside the parentheses. We have 2 to the third multiplied times itself twice. So now we have 2 to the third times 2 to the third to the fourth. So what's 2 to the third times 2 to the third? Well, that is equal to 2 to the 6th. So 2 to the 6th to the 4th. Now we're combining our two rules. We have 2 to the 6th to the 4th. Well, if I have 2 to the 6th times 2 to the 6th times 2 to the 6th times 2 to the 6th, how many 2's do I have? I have 2 to the 24th power. So, to find the power of a power, multiply the exponents. So I multiply 2 times 3. Here I multiply 3 times 2, which is 6, times 4, and that gives me 24. The final rule we're going to learn is the power of a product. In order to find the area of this square, I need to take 4ab to the 2nd power, or 4ab squared. So when we have 4ab squared, that means we have 4ab times 4ab. So that gives us 16a squared b squared. So it's almost like you're taking 4ab squared. This is another way to look at it, is 4 squared. Everything inside each number is going to be taken to the 2nd power, and each variable. And once again, we get 16a squared b squared. So let's look at a couple more examples of this. What I like to do is look at each individual number or variable. So we have negative 4th to the 3rd. We have x to the 3rd times y to the 3rd to the 3rd. So what's negative 4 to the 3rd power? Well, that's going to be 4 times 4, which is 16, times another 4, which will give us 64. But since it's a negative, it's going to be a negative 64 because we have negative 4 times negative 4, which gives us a positive 16. But then we take that times negative 4, and that gives us a negative 64. Since it's an odd exponent, we'll have an odd number of negatives, which gives us an odd result, or a negative result, pardon me. And then we have x to the third, and then we have y to the third to the third. So this is a power of a power. And so we take y to the third times y to the third times y to the third. So that's going to give us y to the ninth. Okay, another way you might want to look at this is just repeating what's inside here 3 times. Negative 4 xy to the third times negative 4 xy to the third times negative 4 xy to the third. Okay, and that gives us negative 4 times negative 4 times negative 4 times negative 4 times x times x times x times y to the third times y to the third times y to the third. And so we have negative 64 x to the third y to the ninth. Now I'd like you to try the following problems using these new rules, and we will check them during your next class period. Have a great evening.